Hey children, it's Wednesday night and I'm going to actually help you on two of your problems tonight. I'm going to help you on problems 2 and problem 4. I'm not going to give you as much step by step, so I'll tell you what I'm doing and then I'll give you a chance to do it yourself and you can follow along. So again, we're still solving systems of equations algebraically. So again, that means I have 2 or more equations and I'm trying to find the x and y pair, the coordinate pair that will make both of these equations true. So yesterday, all of our equations were already solved for y, but as you can already see in our problem right below us, this equation, not both of these are solved for y. So this first one is solved for y, but this second one isn't, which means I first need to solve this equation for y. So we've had practice doing this, so solve this equation for y. If I want y by itself, I should get rid of the x term. Bring down my negative 4y equals negative 5x minus 3. If I want y by itself, I should divide by negative 4. And I get y equals 5 over 4x plus 3/4. Okay, and there I've solved that equation for y. My next step would be to set these two equations equal to each other. So I should actually write down negative 3x plus 5 negative 3x plus 5 equals 5/4 x plus 3/4. And then at this point, I see there's a fraction there. I want to get rid of the fraction. In order to get rid of the fraction, I should multiply by the denominator of the fraction. The denominator of the fraction in this problem is 4. That's why I'm going to multiply both sides of this equation by 4 completely. Make sure we're distributing correctly. Draw your lines connecting so that you don't forget anything. 4 times negative 3 gives me negative 12x. 4 times 5 gives me positive 20 equals. Multiplying the right side by 4 was to get rid of the fraction, so I'm left with 5x plus 3. And then I solve this equation by moving x to one side, adding 12x to each side. I bring down my 20 equals 17x plus 3, and you're probably thinking, oh man, this looks ugly. I'm going to get a fraction as my answer. Trust me, you're not going to get a fraction as your answer because I care about you guys and I don't want you to stress out. I just want you to do math the way that I've taught you to do the math, and everything will be okay. So here we found 1 equals x, or more likely x equals 1. So this is not our solution, this is just part of our solution. Our solution is actually a coordinate point, a pair of x and y values that makes both of these equations true. So I have to continue my mathing. I have to figure out what's y going to equal if x equals 1. So it's my choice which one of these equations I want to plug this into. Given the choice, I want to plug it into the one that's already solved for y. So it's much easier for me to plug in 1 for x here than it is here. So that's what we're going to do next. The equation I'm plugging it into is y equals negative 3x plus 5. I'm plugging in 1 for x, which means I have y equals negative 3 plus 5. Well, 3 negatives and 5 positives means I have a total of 2 positives. This is the second part of my solution, and now I can write my entire solution as a coordinate pair. So I'm going to be writing 1, 2. That is the solution to this system of equations. Okay, next we're taking a look at problem 4. Again, we have the same issue here, which is that one of the equations, the second one, is not solved for y. So the first thing I need to consider doing is solving this equation for y. So if you feel like you can do that part on your own, go for it. Otherwise, pay attention to me. I have negative 2x minus 3y equals negative 7. I want y by itself, so I want the y term to be by itself on that side of the equation. I should get rid of the x term. The x term is a negative 2x. In order to get rid of it, I could simply add 2x to both sides. I bring down my negative 3x, my equal sign, my positive 2x, and my negative 7, minus 7. Okay, I need to do one last thing, and that is I need to make sure that I write my variables correctly, which I didn't. This should be a y, I wrote an x. Negative 3y equals 2x minus 7. If you see here, that's what I should have written there. Sorry about that. Next thing I need to do is I need to make sure I divide everything by negative 3 so that y is absolutely, completely alone. I bring down y equals, a positive divided by a negative is a negative, so this is a negative fraction, negative 2/3 x. And a negative divided by a negative is a positive, so this is a positive 7/3. Now both of my equations are solved for y, so the next thing I want to do is set these two equations equal to each other so I can figure out the x value that belongs in my coordinate point. So that's what we're going to get started on next. I have 6x minus 11 equals negative 2/3 x plus 7/3. Again, what we see is we have some ugly fractions here that I don't want, so I need to get rid of them. I can get rid of them by multiplying by the denominator value, because that will cancel out the fractions. So the denominator value in these problems is 3. So I'm going to multiply each side of this equation by 3. I'm going to make sure I distribute by drawing those lines. I don't want to miss out on anything, because then I'll get the wrong answer. So 3 times 6x gives me 18x's. 3 times 11 gives me 33. Equals, the point of multiplying this side by 3 was to get rid of the fractions, and that's exactly what's going to happen. I get negative 2x plus 7. And if you're wondering, why isn't this 21 or why isn't that 6? It's because when I multiply by 3, it cancels this out with this 3. Cancels this 3 out with this 3. So now I would solve this. My first step in solving this would be to get my x terms on one side by adding 2x to each side. So I'd add 2x here. I'd also add 2x here over to the 18x. I bring down 20x, take away 33 equals 7. And again, you're wondering, Miss Rico, why do you give us such ugly problems? I promise, if you trust me and you do the math I taught you to do, the problems in the math will be beautiful. It's the way I told you it would be. Trust me, children. Divide by 20, I get x equals 2. So if you got lost somewhere around there, that was a two-step equation at the end that I solved without explaining what I was doing, because all of you should be proficient in solving two-step equations. Now certainly I believe you would agree with me if I said, this is not my solution, this is just part of my solution. What do I need to do to find the rest of my solution? That's right, I need to plug that 2 into the x to find my y. So given the choice, would you want to plug it into the first equation or the second equation? Again, you're so brilliant and smart, the first equation, because it is simply easier and it is already solved for y. So y equals 6x minus 11. I am plugging in the value of 2 for x. So y equals 6 times 2 minus 11. Well, that means y equals 12 minus 11. And I know 12 minus 11 is 1. So that means y equals 1. This is the second part of my solution. Now I can finalize my complete absolute solution to this system of equations as a coordinate point. That means x is 2 and y is 1. Those are the values for which both of these equations will be true. Use those two examples to help you get through problems 1 and 2. I'm sure you will find them more manageable now that you have these examples. See you tomorrow.